We'll proceed. Okay. So mirror formula is 1 by V plus 1 by U is 1 by F, right? So we need to derive this. So we'll see the derivation part. But before we see the derivation, leave some space for it. And I need to explain you the rules to draw ray diagrams. So first we will see for a concave mirror. So when I take a concave mirror, so okay, the rules are the same actually. I'll go with concave as well as convex on the same side. Okay, listen. So first is when a ray is considered parallel to the principal axis. After reflection will pass through. So ray which is considered parallel to the principal axis after reflection will pass through the principal focus. Okay. Secondly, okay. I need to draw the ray diagram for this. So when I take a ray parallel to the principal axis, after reflection, what should happen to it? It should pass through the principal focus. So it will pass through this point, right? Whereas with respect to a concave mirror, convex mirror, what should happen? When a ray is taken parallel to the principal axis, after reflection, it will appear as if it is passing through the focus. Means it will appear as if the ray has come from the focus. So small correction, the ray diagram. So it will appear something like this. Arrow marks are very important. Okay. Second is, if you consider a ray through focus after reflection will become parallel to the principal axis. So if I consider a ray like this and in this way, okay, if a ray is considered to pass through the focus, after reflection, it will become parallel to the principal axis. Similarly, if I take a ray which is assumed to be incident at the focus for a convex mirror, after reflection will become parallel to the principal axis. This is how it looks for concave and convex. I hope it is clear. Right? Similarly, the third part is ray through the center of curvature retraces its path. So ray through the center of curvature retraces its path. So why is this even happening? Let's see. If I take a ray through the center of curvature, right? Then the angle of incidence, is 0 degrees. So according to the laws of reflection, what should be the angle of reflection? That will also be 0 degree. That is why this kind of a phenomenon is observed. So same is the case with respect to convex mirror as well. Is something like this, right? And the last point is ray incident at the pole. So if a ray is incident at the pole, will make a symmetric angle with respect to the principal axis. PA is principal axis. I'll take up. Or instead of saying will make symmetric angle, I'll say will be symmetric. Will be symmetric with respect to the principal axis. With respect to principal axis. So the meaning of it is, if this is the pole and this is the incident ray, okay. Now, at the point of incidence, we are supposed to draw the normal. I told you, for drawing the normal, join the point of incidence and the center of curvature. Then this will be the angle of incidence. If this is the angle of incidence, then the same will be the angle of reflection as well. Okay. So that is why I told it is symmetric with respect to the principal axis. So same is the case with respect to a convex mirror as well. So if I take this as I, this will also be I. Is this point clear? Right. So having this in mind, okay, let's see how to draw the ray diagram for different scenarios. I'll draw for 2 scenarios. Remaining things you can have a look at your textbook. So these are the concepts from your 10th standard. Okay. Suppose I take this to be the focus and this to be the center of curvature. If a ray or if an object is placed between the focus and the center of curvature, then what should have happened? If I take a ray parallel to the principal axis, after reflection should pass through the focus. And if I take a ray through the focus, after reflection should pass through the, so parallel to the principal axis. And if I take a ray hitting the pole, it should get reflected back symmetrically. And if I take a ray through the center of curvature, it should retrace its path. So what I'm trying to say is, if I take any of the four conditions of the rays that is to be drawn here, then we will find that the image is located at the same point. So when you locate the position of image, it will be A dash, B dash, and it will be a real and inverted image. Or I can say real, inverted, and magnified image. Because if you see, the size of the object is more, size of the image is more compared to the size of the object. There is one point where it will produce virtual. No, not always magnified. It can produce diminished also. In this case, it is magnified. Beyond the center of curvature. So image will be formed beyond the center. If you take the exact measurements and draw, you will be able to locate the position. Clear? So basically, with respect to a concave mirror, you will have how many ray diagrams? Those who are online, are you able to hear me? Srimitra and Nithilan, are you able to hear me?
Yes, yes, sir.
Okay. So with respect to a concave mirror, how many ray diagrams are possible? 6. Why 6? Because 1 is when the object is placed at infinity. Second, so when the object is placed at infinity, where is the image formed?
Yes.
Yes. Image is formed at the focus. Okay. Similarly, when the object is placed beyond C, where is the image formed? Between F and C. Okay. Third, object is placed at C. Where is the image formed? At C itself. Image is also formed at C itself. Fourth, when the object is placed between F and C, where is the image formed? Just now we drew the diagram. Yes, it is beyond C. Okay. Fifth one, object is placed at F. Image is formed at infinity. So if you observe, the scenario exactly gets this, reversed. If you place the object at infinity, image is formed at the focus. So reverse cases, if you place the object at F, image is formed at infinity. Similarly, If you place the object beyond C, the image is formed between F and C. And if the object is placed between F and C, the image is formed beyond C. Okay. Similarly, if the object is placed at C, image is also formed at C. And if the object is placed between F and P, so if the object is placed between F and P, where will the image be formed?
Behind the mirror.
It will be behind the mirror. This is where the virtual image is formed. Behind the mirror is no. It will be behind the mirror. It will be virtual, erect, and magnified. It will not be diminished. It will be magnified. So for this scenario, I will draw the ray diagram. Observe. So if I place the object here, okay, then when a ray is parallel to the principal axis, after reflection should pass through the focus. I cannot draw that because the object is blocking me. So if I take a ray through the center of curvature, right, it will retrace its path. That is one thing. And when it is incident at the pole, it will travel in a symmetric manner in such a way that these two rays are getting diverged away from each other. So when the rays are getting diverged, there is no possibility of them to meet. So when you extend them backwards, you can observe that this is where the image is formed. So if this is AB, then this will become A dash, B dash. So based on this, we will try to derive mirror formula.
So can you scroll up for a minute?
Sure. Done.
Yes, sir.
Okay. Now we'll see the derivation of mirror formula. So I already drew the diagram yesterday. And if you see, from P to B, this is called as C. Sorry, P to C is called as the radius of curvature. Okay. Now listen to this carefully. So if I take two right angle triangles, right? So for me to do this derivation, I need to use two right angle triangles which are similar to each other. So the first set of similar triangles that I'm able to see are triangle BAP is observed to be similar to triangle B dash A dash B. Okay, because one of the angles in both the cases is, oh sorry, 1 minute, I can write it as ABB. So triangle ABP is similar to triangle A dash B dash B, where B and B dash have 90 degrees and angle B is the same. So according to AA criteria, they both are similar. So from this I can write A dash B dash divided by AB. When two similar triangles are there, we know that their sides are in the same proportion, right? A dash B dash by AB is equal to B dash B divided by BP. Okay. So what is, okay, let's not disturb A dash B dash. So A dash B dash divided by AB, I'm not disturbing it, is equal to, what is B dash B? If you see B dash B is V, because it is the distance between the image and the point where image and the pole. So V, but I need to use a negative sign because it is on the left hand side. Sign convention. Yesterday I told you, while deriving you need to use sign convention, and while solving the problems also you need to use sign convention. So minus V divided by, what is AB? AB is U, but that U is also having a negative sign. So this will be equal to V divided by U. Okay, because both are on the left hand side. So let me take this as equation number 1. Okay. In a similar way, if I am able to look at the other right angle triangle that I have, then I will take it to be okay. So for that, I need to draw another diagram. First, copy this. Okay. So one of the rays we took to be incident at the pole, and it got reflected back. The other ray we can take to be through the center of curvature, which will retrace its path. So can I say this is the place where the image is formed? So it's the same thing. 1 minute. So this is how it works. Okay. So one set we already found that ABP and A dash B dash P are similar. We have already proved it. Similarly, I can say ABC, the triangle ABC is similar to triangle A dash B dash C. Can I say that? So ABC is similar to triangle A dash B dash C. So for that, I can say A dash B dash divided by AB is equal to A dash C divided by AC. Right. So I'm not disturbing A dash B dash and AB, which is equal to what is A dash C? Observe, this distance is R. This distance is B. What is A dash C? Oh, sorry. A dash C and I don't need A dash. I can rather take B dash C divided by BC. So because B dash C is along the horizontal, what is B dash C divided by BC? R minus V by AB is AB. BC. BC is not 2R. This is U. So how much is it? Observe BC. BC is this distance. Observe. See, what is BC? BC is BP minus CP. What is BP? Right. So I'm saying BC is equal to BP minus CP. What is BP? That's it. So it is U minus R, but I need to put a minus sign here, though they are getting cancelled. Okay. Then A dash B dash divided by AB will be equal to R minus B divided by U minus R, and I'll call this as equation number 2. Is that point clear? Okay. So what I can do is from 1 and 2. From 1, what is there? A dash B dash by AB is how much? V by U. So R minus V divided by U minus R. Right? So when you cross multiply each other, VU minus VR is equal to UR minus UV. So UV will come to the left hand side. It will become 2UV is equal to UR plus VR. So divide with UVR on both sides. I will get 2 divided by R is equal to 1 by V plus 1 by U. But what is 2 by R? It is 1 by F. So 1 by F is equal to 1 by V plus 1 by U. And this is how it works. And this is what we call it as mirror formula. Yep. So please make a note of this. Did you understand? Okay. So after this, we have another term to be learned, which is called as magnification. So when we talk about magnification, there is something called as linear magnification that is present. Okay. So what is linear magnification? Is defined as the ratio of size of image to the size of the object. No problems. They are not good. Sorry, guys. We'll continue. Yeah. So we are discussing about magnification, right? It is the ratio of the size of the image to the size of the object. So ratio of what is the size of the image? A dash B dash per. So look at the diagram. A dash B dash is the size of the image. Size means height. Okay. Divided by what is the size of the object? It is AB. So if you observe from equation number 1, A dash B dash divided by AB is equal to B divided by U, and this is what is magnification, but I have a small correction to do here. A dash B dash is what? Is it negative or positive? It is negative because it is the downward direction. So minus A dash divided by B dash divided by AB is what is B by U. Okay. So magnification will be equal to, so observe. Okay, I'll write one more step. Listen to this. I'll come to that. So height of the image divided by the height of the object. Okay. This is what is magnification. Now, from 1, what I can say is height of the image is A dash B dash divided by height of the object is AB. So A dash B dash is minus HI divided by AB is H naught. This is equal to B divided by U. But what we need is, we need only HI by H naught. So HI divided by H naught will be equal to minus V by U. So the magnification with respect to a spherical mirror, okay, the magnification with respect to a spherical mirror is minus V by U. Okay. Those who are online are able to understand?
Yes.
Okay. So this is the magnification. Yes. So here an important note to be made is about the sign convention. So if you see for the sign convention process, it is to be applied during and solving problems. Convention applied during and very, very important. And why are we doing it? That any, why do we need separation? Yeah. Okay. Apply sign convention. It's not using if you ray that are available, if you look at the set of ray diagrams that are available for concave mirror, you have 6 ray diagrams, and for convex mirror, you have 2 ray diagrams. So there are totally 8 ray diagrams for which the object position and image position are different at every instant. Okay. If you didn't apply sign convention and you try to derive a common formula, it is not possible because for each scenario you will get a different formula. Means for mirror formula itself, you should have had 8 different formulas, which will be tedious for us to remember. So to make it simple, what they did is they came up with the concept of sign convention even during the process of derivation, so that the same mirror formula is applicable for all the 8 situations. That is the reason. Okay. So this is the reason. So wherever you have multiple scenarios present, you should always go with the concept of sign convention during derivation as well. Is that point clear? Is that point clear to everyone?
Yes, sir.
Okay. So this is all about the mirrors and reflection. So the next concept that we are supposed to discuss is called as refraction of light. So what do we mean by refraction? What happened? So what do we mean by refraction of light? It basically means bending of light when it travels from one medium to another. Okay. So when light is traveling from one medium to another, we can observe that it exhibits the property of refraction where it starts bending. Okay. Convex mirror ray diagrams. Okay. See, actually, as I told you, the 6 ray diagrams are part of your 10th standard. It is not part of 12th. Okay. So that part, nobody will ask you the ray diagrams. You should only know the positions. Okay, bending of light when it travels from one medium to another is what is called as refraction. Now listen to this. Suppose I have a plane boundary. Suppose I have a plane boundary which is separating medium 1 and medium 2. Okay. When I say medium 1 and medium 2, they have different optical properties. What are those optical properties? I'll come to it slowly. So let's say there is a light ray which is incident on the incident on the boundary. Now, if I take this to be the normal at the point of incidence, then this angle is called as the angle of incidence. Okay. So the ray would have actually traveled in this path. This is the actual path. It would have traveled in the actual path had the boundary not existed. Right. So since the boundary is existing, what I would say is it will either start moving towards the normal or away from the normal, depending on what is medium number 1 and medium number 2. So as of now, I am saying, let's say it is moving in this way. In the sense, it has started turning in the clockwise direction and started traveling. Then you can see here the ray has got bent towards normal. Then you can say that the ray has got bent towards the normal. So the other scenario would be ray bending away from the normal. Okay, for this, what we can do is we need to understand the different kinds of media that are present. So when I talk about the different kinds of media that are present, they are classified as rarer and denser. So you have a rarer medium and a denser medium. So what does a rarer medium mean? On a comparative basis, if speed of light in a given medium is more, I repeat it, on a comparative basis, if the speed of light in a given medium is more, then it is classified as rarer medium. Similarly, on a comparative basis, the speed of light in a given medium is less. It is said to be denser medium. So on a comparative basis, the speed of light in a given medium is less. It is said to be a denser medium. So let's try to understand what it means. Suppose the speed of light in a particular medium is 2.5 into 10 power 8 meter per second, and the speed of the light in the other medium is 2.3 into 10 power 8 meter per second. Then here you're only comparing the speed in both the media. So on a comparative basis, you can say that this is the rarer medium and this will be the denser medium. That is what I meant. Because the speed of light, the maximum speed of light is fixed. It is 3 into 10 power 8 meters per second, which is not possible to be more than that. So when you take both the media, you can only do a comparative study and say which is rarer compared to the other. So you say medium 1 is rarer compared to the second medium, and medium 2 is denser compared to the first medium. That is the meaning of it. Okay. So that is the language that we use in physics. Right. Now, based on this, you have a concept called as laws of refraction. So there are certain laws that are associated with refraction. Of which the first law is you have an incident ray, refracted ray, and normal all lie in the same plane. Incident ray, refracted ray, and normal all lie in the same plane. And secondly, ratio of sine of the angle of incidence to the sine of angle of refraction. So ratio of sine of the angle of incidence to the sine of angle of refraction is always a constant. And the constant is termed as refractive index. And the constant is termed as refractive index. So sine I divided by sine R is given as either mu or mu21. So if they simply give you mu, it is called as absolute refractive index. If they give it as mu21, it is called as relative refractive index. Is it clear? So this is how it works. Where mu21 can also be written as mu2 divided by mu1, or I can say that mu1 into sin I will be equal to mu2 into sin R. So if you observe this, we are writing a mathematical expression between the refractive indices and the sine of the angle of incidence and sine of angle of refraction, where this equation is called as, any idea about what is the name of this equation? It's called as Snell's rule. Yes, you call it as Snell's rule. Okay, you would have heard this, but might have in 10th you would have heard this. So it's called as now I need to explain what is this refractive index. So what is by the way, did you guys write down this equation? Yes. Okay. Now let's see what do I mean by refractive index. So refractive index in this context means ratio of speed of light in vacuum to the speed of light in a given medium. So if you're able to call it as the ratio of speed of light in vacuum to the speed of light in a given medium, then you call it as refractive index. So mu is written as C divided by V. Okay, where C is the speed of light in vacuum, which is 3 into 10 power 8 meters per second, and V stands for speed of light in a given medium. So from this, I can conclude that mu is inversely proportional to V. Okay. So when I say mu is inversely proportional to V, observe, I told the speed of light in rarer medium is greater than the speed of light in denser medium, which implies the refractive index of rarer medium is less than the refractive index of denser medium. So whenever they give you refractive index, let's say 1.5 is given and 1.3 is given, by looking at them, you can say, this is the refractive index of denser medium and this is the refractive index of the rarer medium. So this is how it follows. So mu R is less than mu B. Is the point clear? Right? So here, what I gave you is also called as absolute refractive index. It's called absolute refractive index. So similarly, if I want to define relative refractive index, if I want to write mu to 1, then that can be written as mu2 divided by mu1, or this can also be written as v1 divided by v2. Why? Because mu and v are inversely proportional to each other. Is this point clear to everyone? Yes? Yes, sir. Okay. Now, one last concept for the day is, we'll see what happens when light travels from rarer to denser medium. When light travels from rarer to denser medium, what happens? It bends towards the normal. So this is what you would have learned in your lower grade. But the question is, how do you know that? Why can't it bend away from the normal?
So can you scroll up a little bit?
It is because, come again.
So when it goes from rarer to denser, it goes towards the medium because it has something to do with the angle of dispersion. The angle of
Angle,
deviation.
angle of dispersion, is that what you told?
No, so angle of deviation.
Angle of deviation. I've not explained what is angle of deviation till now. Let's see. You're almost there, but if you think slightly, you will get it. So if I say above medium is mu r and the below medium is mu d, and the incident ray is obviously in the rarer medium. If this boundary was not there, the ray would have traveled in the actual path like this, right? So if I say mu r into sin I, so I apply Snell's law like this, okay? I don't write sin I by sin r is equal to mu 2 by mu 1. I write it as refractive index of a medium into sine of the angle in that medium. Sin I will be equal to refractive index of the second medium into sine of the angle in that medium. So in the first medium, if it is called angle of incidence, the second medium it will be called as angle of refraction. So mu r into mu d into sin r. Not to be confused between this r and this r. So mu r represents refractive index of rarer. Sin r represents angle of refraction. R represents angle of refraction. Okay. So from this I can write sin I by sin r is equal to mu d divided by mu r. But according to the definition of refractive index of denser and rarer medium, which one is greater? So denser is greater means this value should be greater than 1. Greater numerator, lesser denominator, the value will be greater than 1. So sin I by sin r should also be greater than 1, which implies sin I is greater than sin r, which implies I is greater than r because sin is an increasing function. Just because sin is sin I is greater than sin r, you should not write I is greater than r. Only if sin is an increasing function, you can write it. That's what mathematics says. For example, if you had a scenario where cos I is greater than cos r, then the answer would have not been I is greater than r, I would have been less than r because cos is a decreasing function. Okay, so you need to be very, very careful with these kind of things. So sin is an increasing function. Is the point clear? Right? So having said this, we can say if I is greater than r, let's say if this angle is I, this angle is also I, which is a vertically opposite angle. Okay. If I is greater than r, then the refracted ray should be in such a way that it is between the actual path and the normal, so that if this is r is less than I. Okay, that is the reason why it starts bending towards the normal. So going forward, when we say bending towards the normal, it is always a clockwise turn. So whenever we say bending towards the normal, remember with respect to the actual path, it should take a clockwise turn. Okay. So using the same logic, you guys can figure out what happens when the light travels from denser to rarer. It goes away from the normal. Away from the normal means away from the normal and the actual path. So from actual path, it should take an anti-clockwise turn. Okay, so that's what happens. So based on this, we are going to see certain applications of refraction in glass slab and a few other places. We'll be calculating something called as real depth, apparent depth, and all those things, which we'll see in the next class. Okay, so that's it from my side for today. Is everyone clear? Nithilan and Sriman,
Clear, sir.
Okay, so that's it. Then we'll wind up. You can leave, guys.